Good morning, everyone. Today we are going to discuss about insolation and Earth heat budget. Insolation is the incoming shortwave energy coming from the sun towards our Earth surface, and terrestrial radiation is the long wave energy reflected from the Earth surface towards the space. Okay, this is the atmospheric absorption. We will discuss in this video more details about this. And surface reflection, atmospheric absorption. Okay, the sun constantly bombards Earth with enormous energy. Okay, at the same time, the vacuum of space is incredibly cold. Why don't we boil during the day and freeze solid at night? The answer lies in an elegant global system that perfectly balances energy, income, and expenses. Earth as a whole neither gains nor loses heat over time. It maintains a constant temperature. This equilibrium is what makes our planet habitable. Okay, now first of all, you have to understand the concept of insolation. What is insolation and what is terrestrial radiation? Okay, insolation is the incoming solar radiation, okay, coming from the sun towards our Earth surface, and terrestrial radiation is the long wave energy. They are outgoing solar radiation from the Earth surface towards the space. Okay, insolation means the energy received by the Earth surface in the form of short waves from the sun. Okay, this is the energy, short wave energy. Okay, from from the Earth and sun. This is a planet income. Okay, this is the we also call this insolation as a income of the planet. Then terrestrial radiation, the energy radiated back into space. Okay, energy radiated back into space from the Earth surface by the Earth surface. This is the planet's expense. Okay, this is the expense. Okay, after all, insolation is the short wave energy coming energy from the sun towards the Earth surface, and these are outgoing energy, terrestrial radiation, from the Earth surface to the space. Okay, insolation is the income of the Earth surface, and terrestrial radiation is the expense of the Earth surface. Okay, now there is another concept known as heat budget. What is heat budget? The perfect balance between the amount of heat absorbed as insolation and the amount of lost for terrestrial radiation. Okay, heat budget is the balance between amount of insolation and amount of terrestrial radiation. Okay, insolation, short wave energy, is equal to terrestrial radiation, long wave energy. This is known as heat budget. Okay, the journey of solar energy begins. Okay, first of all, insolation is the term of the incoming solar radiation that is intercepted by the Earth. However, the amount of energy received is not the same everywhere. Okay, it varies significantly based on location and time. Okay, the amount of solar radiation received by the Earth surface is varies accordingly on the basis of location and time. Okay, on the basis of location on the Earth surface and time. The highest yearly insolation occurs in the tropical regions. Okay, in the tropical regions the highest insolation, and steadily decreases towards the pole. When we move towards the pole, the insolation is received by the Earth surface is become less. Okay, decrease towards the pole. Similarly, summers receive more insolation. Okay, during the summer season, Earth receive more insolation, and then winter. Okay, winter receive less insolation. Okay, understanding what controls this variation is just first step to understanding our planet's climate. Okay, now go to the factors. The factors, there are some determining factors of received portion of insolation by the Earth surface. The factors are angle of incidence. Okay, angle of incidence means the rays received by the sun rays received by the Earth surface. Okay, near the pole, the sun rays are slanted, spreading the same energy over a large area. Okay, this is the same energy. This is the same energy, but it spreads towards a large area. Okay, that's why low intensity. The diffuse energy is in low intensity. On the other hand, in a near the equator, concentrated energy, that means high intensity. Each and every area received high intensity, that's high temperature. The sun's rays are nearly vertical, concentrating energy over a smaller area. Okay, in the equator, each and every unit received high insolation, high energy, and in polar area, the diffuse energy and low intensity, and each and every region has received low energy, low temperature, low insolation. Okay, because the Earth is a sphere, the sun's rays strike the surface at different angle. Okay, they are different angle depending on latitude. Okay, different angle depending on their latitude, different angle depending on the latitude. Based on the latitude means the angle between parallel and Earth center, and longitude means the angle between meridians and earth center. Okay. Meridians and earth center and the prime meridian, Greenwich prime meridian. Okay. Above all, different angles receive different amount of insolation, and in different latitude depending on different latitude, the insolation received is varies. Coming to our next region is the Earth's tilt. Okay, this is June solstice, December solstice, autumn equinox, vernal equinox, or spring equinox. Okay, key factors: rotation creates the day and night cycle, ensuring the how the planet receives insolation at any given time. Revolution and axial tilt: the Earth revolves around the Sun with its axis tilt at 23.4 degrees Celsius, 4 degrees not Celsius. This constant tilt means that for part of the year the northern hemisphere is tilt towards the Sun. Okay, northern hemisphere is tilt towards the Sun. This portion. Receiving more direct rays, okay, and longer days, it's summer, and for other parts it is titled tilt away, it's tilt away. Okay, this is the southern hemisphere, and it receives lower amount of insolation. Another day is day of length. Okay, day of length and the transparent sky. Okay, factor 1, duration of the day. The longer the day, the more insolation received. If the day is long, then it received more insolation. This is why polar regions can warm up in summer despite the low sun angle. At the Arctic cycle, 66.5 degree north, the sun never sets on the summer solstice, June 21st, a phenomenon creating the land of the midnight sun. And factor 2, transparency of the atmosphere means cloud cover and dust or water vapor. Okay, the atmosphere is not perfectly clear. Cloud cover, dust particles, and water vapor can reflect, scatter, or absorb incoming solar radiation before it reaches the ground, like in this way. Solar rays coming and reflected by the clouds towards the space. The solar radiation, solar insolation is not received by the Earth's surface. Okay, absorb incoming solar radiation before it reaches the ground and reach the ground. A thick cloud cover significantly reduces the insolation reaching the surface. Okay. Now, to track the energy, let's assume the insolation received at the top of the atmosphere is 100 units. Okay, 100 units come from the sun as the form of insolation towards the Earth's surface. As this energy passes through the atmosphere, a significant portion is immediately reflected back. Towards the space. This reflective quality, okay, of the atmosphere is known as albedo. Okay, this is the space. Suppose this is sun, an insolation coming towards the Earth's surface, and after receiving the atmosphere reflect a portion of the received insolation from the sun, and this reflected portion of insolation is known as, or reflective quality of the atmosphere is known as albedo. Okay, albedo analogy. Think of albedo as a Earth's clothing. Wearing a white t-shirt like snow and ice reflect the sun's heat and keep you cool. Okay, a dark asphalt road absorb it and getting hot. If atmosphere consisting of greenhouse gases, then the insolation will be absorbed, and then the temperature of the atmosphere will rise. This is known as greenhouse effect. Okay, 100 units comes towards the Earth's surface, and 35 units sent back towards the space from the Earth's surface through atmosphere, and this reflected portion is known as albedo. And from this 35 units, out of these 35 units, 27 units reflected from cloud, 2 units reflected from snow and ice, and 6 units reflected through scattered by atmosphere. Okay, so 27 plus 2 plus 6 is equal to 35. Okay, another 65 units reach the Earth's surface. Okay, the breakdown of reflection of the 100 units, that is the 100 units of incoming insolation, a total of 35 units, this is 35 units, also known as reflective albedo, are reflected back to space and play no role in hitting the Earth. Okay, this is the Earth's total albedo. 27 units are reflected from the tops of cloud, 2 units are reflected from snow and ice covered surface, 6 units are scattered by the atmosphere and sent back to the space. Now, out of 65 units received by the Earth's surface, 51 units direct reached towards the Earth's surface, and 14% absorbed by the atmosphere. Okay, 14 plus 51 is equal to 35. Okay, absorbed energy within 35 units reflected, with 35 units reflected, the remaining 65 units are absorbed, providing the energy that hits our planet. Okay, 65 units reach the Earth's surface. Okay, where out of 65 units, 55 units pass through the atmosphere and are absorbed directly by the Earth's surface, land and oceans, and 14 units are absorbed directly by the atmosphere by components like water vapor, dust, and greenhouse gases. Okay, out of 65 units, 14 units are absorbed by atmosphere like water vapor, dust, and greenhouse gases, and 51 units directly reached our Earth's surface. Now, after that, the Earth, having absorbed 51 units of short-wave solar energy, heats up and radiates that energy back in the form of long-wave infrared radiation. Okay, out of 51 units, 17 units radiate directly from the surface through the atmosphere and into space. Okay, 17 units, these 17 units reflected directly from the surface through the atmosphere into space, through the atmosphere. Okay, 17 units, and 34 units are absorbed by the atmosphere on their way out. Okay, they do not reach the space, they absorb by the within the atmosphere. But 34 units and 17 units. 17 units reflected from the surface through the atmosphere, and 34 units absorbed by the Earth's surface. 35 plus 17 is equal to 51 units. That is terrestrial radiation. Okay, now balancing the atmosphere's budget, the atmosphere itself must maintain an energy balance. Let's tell you its account. Income 1, it absorbed 14 units directly from incoming sunlight, then absorbed 34 units or outgoing long-wave radiation from the Earth's surface, and total atmosphere absorbed on what? 14 plus 34, that is 48 units. Okay, 14 units directly from incoming sunlight, as we have earlier learned, and 14 units, and 34 units outgoing long-wave radiation from the Earth, and total 48 units total atmospheric absorption. To stay in equilibrium, the atmospheric most radiates these 48 units back out to the space. Okay, atmosphere, the reflected portion of insolation is 48 unit by the atmosphere to the towards the space, 48 unit. Okay, let's check the final math of the entire Earth systems. Okay, incoming, again we repeat the same phenomena. Incoming 100 units towards the Earth surface. Out of 100 units, 35 units directly reflected towards the space, and that means 27 from cloud, 2 from snow lines, and 6 from scattered, 35 units, and 51 units received by the Earth's surface, and 14 unit absorbed by the atmosphere. Okay, total 51 plus 35 plus 14 is equal to 100. Okay, then within this 15 unit, okay, from this 15 unit, 17 unit reflected towards the directly from the Earth's surface. Okay, there are 17 units directly Earth's surface, and another 34 units reflected through the atmosphere. Okay, 34 for the atmosphere, and total 34. Okay, let's learn about total energy absorbed. 65 units, 51 by surface and 14 in by atmosphere. 65 units by surface and 14 units by atmosphere. Okay, 51 plus 14 is equal to 65. Total energy radiated to space, 17 unit directly from the Earth's surface, 17 unit directly Earth's surface, and 48 units radiated by the atmosphere. 48 units radiated by atmosphere. This 34 units and 14 units radiated by atmosphere. Now total outgoing 17 plus 48 is equal to 65 units. Okay, 17 plus 48 is equal to 65. Okay, the budget is balanced. Okay, the Earth received 65 and radiated 65. Okay, the budget is balanced. The Earth maintains a stable temperature because the energy it absorbs is precisely equal to the energy it radiates back to space. Now the latitudinal imbalance, there are some difference between Earth's insolation, radiation and insolation. Okay, latitudinal according to their latitudinal variation of the Earth's surface, latitudinal imbalance, while the Earth as a whole is a balance, different latitudes are not. Okay, and there is a difference between the latitudinal extension. Energy surplus, okay, heat surplus region, equatorial region from 0 degree to 40 degree north and 0 degree equator to 40 degree south. In within this region, we known as this portion as a heat surplus region. Means insolation is higher than radiation. Okay, in the tropical and subtropical zones, roughly between 40 degree north to 40 degree south latitude, the amount of incoming insolation is greater than the outgoing terrestrial radiation. Okay, and the amount of incoming insolation is greater than outgoing radiation. Okay, these regions gain more heat than they lost. Okay, these regions gain more heat. That's why it's warm than other regions. Energy deficit in the polar and upper mid latitudes beyond 40 degree to north and south. That means for this portion and this portion. The amount of outgoing radiation is greater than the incoming insolation. These regions less more heat than they can. That's why these regions temperature is less than other equatorial region. Okay, the greater redistribution nature corrects this latitudinal imbalance. The excess heat from the surplus zone is constantly being transported toward the deficit zones. The mechanism, this massive heat transfer is accomplished by two primary factors process. First of all, ocean currents and atmospheric circulation. Vast ocean circulation patterns move warm water towards the pole. In atmospheric circulation, these winds, global wind systems carry heat and moisture away from the tropics. Okay, this constant flow of energy is the ultimate cause of all our climatic fixtures, from pressure systems and stormy weather in the latitudes to global wind patterns. Okay, the heat budget is not static; it's a dynamic, planetary, and scale engine. Heat budget is not permanent. It's temporary. It may dynamic according to their planetary scale engine, then ocean current and atmospheric variations. Okay. From a singular sunbeam to a global climate system, first of all, arrival, the sun energy insolation arrives its intensity dictated by Earth's tilt and angle of incidence. And interaction, a portion is reflected, that is albedo, while the rest is absorbed by the surface and atmosphere. Then temperature, the Earth radiates heat break the terrestrial radiation with the atmosphere moderating its escape. Balance, the global heat budget remains in equilibrium with energy in equaling energy out. And consequences, this portion creates a latitudinal heat imbalance which powers the ocean currents and winds that define our world's climate and make it habitable. Okay, insolation, terrestrial radiation. Okay, these are basic concepts. Albedo is important for your exam perspective. Okay, that's all for today. If you have any doubt and queries, just let me know in the comment section. Thanks for watching. Thank you.